This video is an overview of the amino acids. It's going to be the first video in a playlist, and the majority of the playlist will be for the individual amino acids. I'm going to use this small view program to show you the structure of amino acids. They all start with a central alpha carbon. So yes, I'm talking about the 20 alpha amino acids that we're all familiar with or will be familiar with. So from that central alpha carbon, you have an amino group and a carboxylic acid group. So let me just draw those real quick. Okay, and the alpha carbon is going to have one hydrogen, and it'll always have some side chain. So I'm going to just show a methyl group, which this will be alanine, which I've already previously searched here and showing on the side here. So I guess real quick, just to mention, this is kind of just the normal neutral molecule, but at a cellular pH, you're going to end up with the amino group becoming positively charged and the carboxylic acid group becoming a negatively charged ion. I think it's a Zwitter ion, since it's got positive and negative charges on one molecule. So this is kind of what your amino acid is always going to look like, with this side chain here being one of 20 different varieties. So let me just search for alanine. It's going to be slightly, drawn slightly differently, slightly different. But here's still your alpha carbon at the middle of it, and your carboxylic acid on the side, and your amino group on the other side. So this is the N terminus and the C terminus. And if you were to, connect this to another amino acid, your N terminus would be over here for your second amino acid, going off to its alpha carbon somewhere, ... and you're going to end up, this will be a dehydration reaction. So this oxygen is going to kind of get knocked off, and this amino group is going to have a covalent bond to the carbon here. I think it's going to delete it if I click here. Oh, okay, good. So this nitrogen would end up bonding to this carbon here, and this would end up being a little water molecule floating off. This is probably the peptide bond, even though I usually just think of it as a dehydration reaction. So yeah, here's the 3D view of it. You have your N terminus and your C terminus here, and the amino acids that are useful in our bodies are all like the left-handed enantiomers. So you have, with the N terminus on the left, you always have the functional group kind of coming out towards you, and the hydrogen molecule off, projected into the distance. So here's the Wikipedia page for amino acids, and there's a lot of useful information. Normally the side chain is just drawn with the letter R, so you'll see that a lot, and then we're talking about the alpha amino acids. But the main thing I want to bring up, actually in a second, this is a nice little chart showing the 20 amino acids grouped by positive side chains, negative side chains, non-polar side chains down here, polar uncharged side chains. So they're going to have a slight delta charge on them. because they're polar. And then special cases, which sometimes show up as polar uncharged and various things. This would be the 21st, actually, selenocysteine, where you have a selenium molecule instead of the sulfur. But there'll be more about that later when we go over just the individual amino acids. But the main thing I want to show you here is just this table of amino acids. If you sort by the abundance in proteins, this is the order I want to go through them because it just makes them a little bit more, I guess, applicable. You know, it means something. Leucine isn't just a random amino acid. It's the most abundant by percent in proteins. So we'll start with leucine and kind of go through this list in order. All right. I guess just to wrap it up, the abundance here is just the total abundance. And if you click on the reference here and go to that article, you can see that they've actually they pulled it all from a database, but they've separated by viruses, archaea, bacteria, eukaryotes. So the main thing I'm focused on, at least in this context, the amino acids in the context of eukaryotes. If you kind of compare the eukaryotes with the total, they're pretty close, and I think the order is going to be pretty much the same. So I'm going to go through the order here, kind of just assuming it's the same order for eukaryotes and humans, and should be pretty, I guess it pretty much applies to anything you study, but these videos will kind of have a little bit of a bias towards humans and eukaryotes.